notice, and this is the typical copyright. We continue with the mathematics syllabus for CSEC 2018 to 2027. Schedule of videos by the end of this month, September 2024. I hope to have all 32 videos from section 1, number theory and computation, published. And then in October next month, section 2, consumer arithmetic, November 2024, sets and so on, measurements by the end of the year. Then in January 2025, statistics, and February, algebra, March, relations, functions, and graphs. And then in April 2025, geometry and trigonometry. And finally, by May, mid-May, vectors and matrices. Just a reminder that I have divided section 1 into 32 videos, all of which will be made available on YouTube in their entirety. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. And these 32 videos actually cover the math schoolwork up to the end of Form 3, which is grade 9. That is over a 3-year period from Form 1 to Form 3 in secondary school. We are now here. We already did most of this in video 6 when we were talking about addition, subtraction, multiplication, and division of whole numbers. That was an extremely long video because about half of the first part deals with base 10. So we will go over that again. Basis to be continued in the next video and the next one, video 18. So the objective we are looking at is 7 in section 1. State the value of a digit of a numeral in a given base. And the explanation CXC gives is place value and face value of numbers in base 2, base 4, base 8, and base 10. I have divided this objective into 3 videos. Video 1, base 10, and then in video 2, we will deal with base 2, and video 3 for this objective, this should be 7. We will deal with bases 4 and 8. So recall we said that base 10 has 10 digits from 0 to 9. Other number bases follow a similar pattern, that is to say, base 2 has 2 digits from 0 to 1, well, 0 and 1. Base 3 has 3 digits, 0 to 2. Base 4 has 4 digits, 0 to 3. Base 5 has 5 digits, 0 to 4, and so on. Base 8 has 8 digits, 0 to 7. Base 16 has 16 digits, 0 to F, that is to say, A represents 10, B represents 11, C 12, D 13, E 14, and F is 15. Notice that the base itself is not one of its digits. For example, 8 is not a digit of base 8, and neither is 2 a digit in base 2, and so on. In this objective, CXC requires that you know just the place and face values of digits in a numeral in these 4 bases only. But we will look at a general principle, so any other base will be easy to do. So we are dealing with place and phase values in base 10. Now, base 10 is the number you're accustomed to using. If I were to ask you to write 456, or you may say 456, this is what you will not do. You will not write a 400 there, followed by a 50, followed by a 6. You will not do that. Rather, you will do this. In writing that 4, you understand that that 4 is in the hundreds position, and if not, we will make that clear during this video. This 5 is in the tens position. This 6 is in the ones position. So it's like you write the 400 first, and in writing 400, there's a space here for 50. And in that 450, there's a space here for the 6. So 456 is written this way, not like that, not like that. If I were to ask you to add these numbers without a calculator, most likely you will write it down like this: 475, and then you write the 89 like this with the 9 under the 5 and the 8 under the 7. And then you write the 7 like this with the 7 lining up with that 9 and that 5. Of course, you add them. So why set the numbers down like this with the 5 and the 9 and the 7 all lined up? That is this 7. And then that 7 and this 8 lined up in a column. And then this 4 way out here. Of course, you could then add. What you will not do is this. You will not put this 8 under that 4, nor this 7 under that 8, nor, well, this 9 also is in the wrong place. That 9 needs to go under that 5 as we have it over here. You will not do this. Something is wrong, and we will find out what is wrong. The truth of the matter is this 8 is in the wrong column in terms of place value, and so is this 9, and so is this 7. If you don't understand that, by the end of this video, it will be made clear. So we will not do that. So let us say you are counting some stars. We drop a little grid like this on the left. In this rightmost column, you could put up to 9 units or 9 stars. But once you get 10, you have to do something with it, which we will see shortly. So base 10 has 10 digits. So let's count some stars. 1, 2, 3, 5, 7, 8. At this point, you have 8 stars, so you could write 8 like that. 8, 9. So far, so good. You can write 9 here. But if you put one more star, you cannot write 10 in this. Base 10 doesn't have 10 as a digit. So what you would have to do is take all of those 10, put them in one group, and move that group over on this side here. So now you have 10, but 10 means one group of 10 and no ones. So let's count some more stars. That would be 11, 13, 14, 15, 16. That is a group of 10 over here and 6 individual stars over here. If we were to write that down in base 10, we will write this. We write 16, but we do not generally think that in 16 we have one group of 10 and 6 single stars. We sometimes think of 16 as this: a bunch of stars jumbled up together, 16 of them. Not in terms. So that is because there is a smooth transition from 9 to 10, or 19 to 20, and so on. 199 to 200. There is a very smooth transition, and you do not know that you are actually separating it out into groups. So that would be 17, 18. some more, 19, 1, 9. We think of 19 stars. Actually, it's one group of 10 and 9 single stars. If we add one more, that's 2, 4, 6, 8, 10. You know we can't write 1 there and put 10 here. You know we can't do that because in base 10, we don't have a digit that is 10. So we will take those 10, create a new group here, move that group over here. At this point, we have two groups of 10 and 0, 1. But you see that as 20 and do not generally think that that is two groups of 10 and no ones. Add some more. That would be 4 more. So now we have 24 stars. That is two groups of 10, as you could see on the left here, and 4 single stars over here. Now, let's fast forward a little. Assuming that we were counting many more stars, at this point, we have 9 groups of 10 and 8 single stars. So that's 98. If we add one more, we now have 99. We add one more, we can say that's 2, 4, 6, 8. We can say 90, 10. Now, little children would do that when they're learning to count, but we can't do that. We can say now we have 90, 9 groups of 10 here, and 10 here. We cannot say 90, 10. So what we'll have to do is take those 10, create a new group like we have on the left here, and move it over. Now you have 10 groups here, but remember, we can't use the digit 10. Well, 10 is not a digit in base 10. So we will have to take all of those 10, create a larger group, and put them over here. So now you have, this column could take up to 9 groups of 10 of 10s. So we have one red group that contains 10 blue groups, and in each blue group we have 10 single stars. So that's 10 of 10s. We know that better as 100. Counting some more stars, 1, 2, 3, 4, 5. At this point, we have 105. As I said, we generally think that as a jumbled a group of 105. Actually, this 100 position means you have one group of 100. You have no 10s, and you have 5 individual stars. So let's fast forward a little more. At this time, we now have 2 groups of 10 of 10s. That is 2 groups of 100. We have 2, 4, 5 groups of 10s. And we have 2, 4, 6, and we have 7 ones. So if we were to write this that we have here as a number, it will be 257. 2 hundreds, meaning 2 groups of 10 of 10s, 5 10s, that's 5 groups of 10, and 7 ones or 7 single stars. Notice that this 2 is in this position here of hundreds. This 5 is in that position there of 10s. 7 is in the position, the place it is ones. So 257. So let's fast forward now. Lots of stars. At this point, we have 900. We have 9 10s. And we have 7 ones. So that would be 997. If we add one more star, we get 98, 99. So far, so good. If we add one more, as I said, you cannot write 10 here. So you have to take those 10 stars put them in a separate group, move that group over here. But now that creates a problem in this group because we now have 10 here. So we take all of those 10, groups of 10, create a new group and move it over here. Okay, that creates a new problem here because now we have 10 groups here. So we will take all of those 10, create a much larger group, this yellow group, and put all of them in there. So that this yellow group has 10 red groups, and each red group has 10 blue groups, and each blue group has 10 single stars. So that is 10 of 10 of 10s. If you multiply that, you will get 1,000. So that is a 1,000 position. This is a hundreds position. This is the tens position or place, and this is the ones. Fast forward, we now have 3 of this. We have 5 of that. We have 7 of this, and we have 2 of that. So if we were to write that number, 3 there, 5 there, 7 there, and 2 there, we would write like this: 3,572. We will not write this. We will not write a 3,000 first, followed by a comma, then a 500, followed by a comma, then a 70, and then a 2. We will not do that. And that is because when you write this number like this, each digit is located in a particular position or particular place. So this 5, for example, is located in the hundreds place, and that 7 in the tens place. But we certainly will not do this down here. So we certainly will not do this down here. We will write it like that. If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to the channel. It doesn't cost you anything, and it means a lot to me. So let's look at this grid. Remember, we are dealing with place value and face value. So far, we haven't said anything about face value. That is very easy. Place value is what we are concentrating on right now. So still in base 10, you have the ones or the units in that column. That's a 1. You'd have groups of 10 in this column. That's 10. You have group of 10 of 10s in this column, and each column could take up to 9 such groups. And then in this column, you have 10 of 10 of 10s. And over in this column here, you would have 10 of 10 of 10 of 10s, and so on. Now we know these numbers better as 1, 10, 100, 1,000, 10,000, 100,000, and so on. Of course, it can be written in index notation as 10 to the second power, 10 squared. This one, 10 cubed, 10 to the third power. This, 10 to the fourth, as you can see, 4 tens being multiplied by itself there. 10 to the fifth, 10 to the 1, and of course, we know this one is 10 to the 0. We said before that anything to the 0 is equal to 1 except 1 itself, which is undefined. So if you consider this number, 45,642, if you were to write it in this grid, this 4 is in the 10,000 position. So we'd have to write it here, 4. This 5 is in the 1,000 position, so it falls in this column here. This 6 is in the hundreds position, so it falls in the hundreds position. So let's take another number, 23,674. That 2 is in the 10,000 position, so you write it here. 3 is in the 1,000 position. 6 is in the hundreds position. 7 is in the tens position. And 4 is in the ones position. Now the face value is exactly what you see, irrespective of where in the number it is located. So this 3 is 3. And if it were over here, it will still be 3. And if it were way over here, it will still be 3. That is the face value. Now the place value varies. That depends on where in the number it is located and which base is in use. In this video, we are looking at base 10. Let's consider this 3 here. It is in the thousands position. So its place value is 1,000. If you had a 3 here, that 3 is now in the tens position. So its place value is 10. And so on. And this is base 10. In base 2, these numbers here will change. Base 4, they will change. So depending on where in the number the digit is located and which base we are dealing with. As I said, in this case, we are dealing with base 10. So this is the basis of base 10. As a matter of fact, you see clearly here, 10 to the 5th, 10 to the 4th, 10 to the 3rd. So the base is 10. The place values are in powers of 10. So that's base 10. But there are other bases. For example, in base 7, a similar pattern follows. You have 7 digits, and 7 is not one of them. So this first column here is 7 to the 0, just like 10 to the 0, which is always 1. This next column here is 7 to the first power, unlike that one there, which is 10 to the first power. So this first column will be the 7th position. And this next column in base 7 will be the 49 position, place value. And so on, 343. In base 3, the 3 digits are 0, 1, and 2. So this first here would be 3 to the 0 power, like any of the other bases we are looking at. This first position, which would give you 1. But this next one here will be 3 to the first power, which is 3. Up here it was 7, and up here it was 10. Next, 3 to the second power, that would be 9, and so on. So as I said, the place value depends on where in the number the digit is placed and which base we are dealing with. Base 10, just to review again, this is the ones column, that's the tens column, and so on. Now over on this side is the 1/10th column, and 100th, 1,000, 10,000. It's the opposite of what you have on the left. So if you match that one with this, you can match this one with that, and then that one with this, finally this one with that. So that this position here is 10 to the 3rd power. This position here is 10 to the negative 3rd power. That is 1 over 10 to the 3rd. So here are the actual numbers: 1, 10, 100, and so on. 110, 100, 1,000, 10,000. So if we look at a number like this, put it in this grid, the 4 goes in the 1,000 position, which is here. 5 in the hundreds position, and so on. This 8 goes in the 1/10th position. So that would be 8/10ths. This 3 here goes in the hundredths position, and so on. look at two more numbers. 21.4798. Pick any digit here. Let's say this 4. That 4 is in the 10th, 1/10 position. This 2 is in the tens position. This 8 is in the 10,000th position. Or you take a number like this, 70,090. This 0 is in the ones position. This 9 is in the tens position. Just to make sure we all understand this, place value is defined as the position that a digit occupies in a number. 5,735.21 base 10. This 7 here, what position does it occupy? It occupied the hundredths position. So the place value of 7 is 100. And of course, this 2 here is 1/10, tenths position. Face value now, we didn't say much about that, is the actual value of a digit in a number. It doesn't matter which base you are doing, and it doesn't matter where it is placed in the number. If you see a 9 there, it is a 9. So the face value of this 7 is 7. Place value of that 7 is 100. Face value is 7. Place value of this 2 is tenths. Face value is 2. So we need both the face and place values in order to determine what a digit means in a number. Okay, how well did you? Let's consider this number here, and in that number, we will consider the digit 5. What is its place value? Where is it located among those other digits? Well, it is in the tens position. That is its place value. What is its face value? It's 5. You have 5 tens in that position. Let's consider this next number here, 2.089, and the digit we want to look at is the 2. What position is that 2 in? What is its place value? Well, it's in the ones position. And what is its face value? Exactly what you see there, 2. Next number, 3,675.24. We will consider the 2 here. That's the 2 here. Now you know that is 1. This will be 1/10. So it is in the 10th position. What is its face value? Exactly what you see there, 2. Consider that same number again, but this time we will look at a different digit. This 3 up here. What is its place value? Where is it placed in that number? Well, it is placed in the thousands. And what is its face value? Exactly what you see there, 3. Next number, 259.467. We will consider the 6, which is this here. That is in the hundredths position, 1/100. And what is its face value? 6. 3005, let's consider the 5. This is very easy. It's in the ones position, and what is its face value? 5. Lastly, 1.000, and we will consider this 0 on the far right. What is its place value? Well, remember, this one here is 1/10. That one is 100. This one here will be 1,000. So that is its place value. And what is its face value? Exactly what you see here. If you didn't know this before, hopefully now you know it very well. And you need to understand that because these same principles apply to all other bases. So this is what we have been looking at: base 10, place value, and face value of a digit in a base 10 number. So if you consider this number here, 3,506.87, each digit has its place value, and it has its face value exactly the number that you call. And that brings us to the end of this video, video 1 of Objective 7 in Section 1.